Hi everyone, welcome to our day two of Arrays Mastery Series at Aarush coaching classes. If you are new here, subscribe to our channel for structured DSA content. Today we are mastering our first powerful pattern exclusively on array. Okay, and so let's move to today's agenda quickly. So yesterday, what we covered was arrays, memory model, and contiguous storage. That's what we talked about mostly because we were just clearing the basics first. Then we implemented the traversal on the 1D and 2D arrays, including the linear search on both. And we just briefly talked about the time and space complexity though it was brief, but today I will try to explain as much as possible while solving the problems because it is always better to learn while doing. Okay, the theory, as I asked you in the last session, what when you try to learn DSA, why do you don't do it? It just bores you because of the theory or because you first try to optimize. There are two main things, correct? So if you want to achieve all the thing while you're starting learning, that's not going to be best working for you, right? So that's why let's try to learn most of the things which really matter while we are solving the problems. Okay, I think that would work, right? So let's just quickly go towards the today's agenda. So today what we are going to discuss is two-pointer technique. We will dive deep into it because this is one of the most important patterns on which mostly questions are given in the interviews, including all the Mang companies. Okay, so we will be focusing upon here. Then multiple array reversal approaches we will look into. Then pair some problem most frequently asked question in all the interviews, and everyone who is learning DSA should know how to solve this kind of problem. Okay, because see, just learning or remembering things what to solve, okay, is not gonna work for you. But you should always know what you did, why you did. I mean, why you did what you did in a particular problem. That will create an understanding of the pattern for the problems and how you're gonna solve them. So that whenever a new problem is in front of you, you'll be able to solve it. Okay, you don't need to just recollect कि अच्छा ये क्या था and every line of code, and while you are writing it, it's not working because you have missed something and you're not able to recollect because you didn't know or know the gist of the idea how you solved it. Instead, you tried to just memorize it. Okay, so that doesn't work actually in real life. Later we will move to the detailed complexity analysis, and each and every stage whenever something is completed, I will try to show you the tabular comparison of all approaches. Okay, this will give you a pictorial, you can say, memory of what you achieved finally, and that comparison table will be very helpful for you to remember things. Okay, not a pattern but the clear comparison. Pattern you need to, I mean, understand and get the feel of it. Okay, so let's have a quick warm up is going to be around, just have a quick question because this is I'm going to discuss, but before that I'm going to talk about most of a technique two pointer. But before that, I'm leaving you with this question. Think about it for a few seconds. Okay, how would you reverse this integer array commit approach? Okay, you can write your answer in the comment quickly. I know there are too many random answers, and if you think that your answer might be wrong, don't worry about it. Everyone is beginner here, okay? So don't worry. Whatever you feel like is right, just go with it, okay? So while you're writing, let's move on to a new approach, okay? So what is the approach? Two-pointer technique is what I wanted to teach you today. So two pointers eliminate nested loops on arrays converting order n square to order n. Okay. This I will explain you later. Don't worry. Just try to absorb it because I always recommend my students don't just go into the theory. Okay. Remember the visualization. So what this term itself is telling you, two pointers. Okay. So focus upon this, nothing else. Obviously, you are learning this technique because it is gonna do something in a better way. Otherwise, you people already know the brute force means the most naive way that you can think of to solve a problem. Okay. If that was okay for us, then we want to be learning this particular thing. We need this because that was not good enough for us, the earlier approach, okay? Or the most basic approach, whatever you can think of in your mind. So this we will discuss later, don't worry. Let's focus upon this thing. Two pointer. So array specific patterns are there in the two pointer. There are usually majorly two ways, but there is third way also. I will tell you later. Don't worry. So first is the converging pointers for which is particularly here we are going to use in reversal. There is a term called palindrome also. I will tell you what it is. It is completely similar. Don't worry. Okay, in which what happens actually is we take two references. Let's say this is gonna be my array. Okay, one, two, three, four. Okay, four items are there. So converging the pointers. So obviously the indexes are gonna be 0, 1, 2, and 3. Let's say I have my first pointer, which is nothing but the reference here, as this is the left side. So let me call it L pointer, okay, the left pointer. And this is my right hand side. So let me call it the right pointer, R pointer, okay. So this is what this is telling. This first thing is telling you converging pointers. So initially we keep these two pointers at the very end of our array. Later you can use it or implement it on the strings also. Same idea. Doesn't matter. Okay, don't worry about it. So once we start with the two endings, what do we do next? So somehow I'm not going deep because while we solve the problem, we'll talk about talk more about it. But the whole idea is these two pointer we use to traverse the whole array. Earlier, what we did was we started from zeroth index in the last class, then first index, then second index, then third index, and so on. And this is a very small array. No? Here, the size of the array is 4 only. But what did I tell you in the last class? N can be, because in actual or real life, you can say the data is not this small. Data is always in the order of billions. 10 power 9 के order में होता है mostly. Okay. So traversing the whole array, one item at a time, one, 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 one. So you go this way. Okay. Here again, we are going to traverse all the item, but it's just that the way of traversing is a bit different. Different. What is that? We are using two pointers, left and right. So once we have traversed this and this, we'll try to traverse this and this. So that's why it was being called as convergence. You know? That's why it is written converging pointers because these two pointers are converging towards itself. And where do they get stopped? Where do they get stopped? Just when they reach near to each other, they don't need to cross. Okay, these don't need to cross each other. Okay, these don't need to cross each other. So that's what is going to happen. Let's come to the next part. So this is the first one. We're converging. These pointers are converging. Next is equidirectional for sliding window. This is the term which we will learn later, don't worry, or the fast and slow patterns. In this particular pattern, what happens is, let's say this is your array, okay? Your both pointers, the left one and the right one, okay? Both move in the same direction to solve some particular pattern based problem, okay? Both move in same direction, okay? Obviously till the end because you can't go beyond that. That's why they both are starting the slow and the fast. Or the yeah, I think we don't need to write left and right here because both are starting at the same position. So either you can call it pointer one, pointer two, okay, first pointer, second pointer, or the slow and the fast pointer, whatever you want to call. Okay, and that would make more sense. Now, the third one that I was talking about, which is not mentioned here, because third one doesn't get applied on a single array. Actually, third approach is it get applied on two arrays combinedly. Let's say you have 2, 5, 8, and 9. In the other array, you have 1, 4, 7, and 10. Okay, this is array A, this is array B. So you want to create a new array having all the items from A and B in sorted order. So now here you can see A sorted in itself, 2, 5, 8, and B sorted in itself. You just need to create a third array named C where you are going to merge all these items. So here exactly what you are going to do is take one pointer, okay, let's say P1, and take another pointer P2, okay. So I am not going deep into the logic how to exactly merge because that's another topic, but I'm just showing. Now these two pointers are used to compare because in array C we are merging these two arrays, but the output should be in sorted order. So just apply your logical mind, try to put it or narrow it down to the break it down to your common sense and think what kind of comparison should be happening here so that we can decide what item to put in C here. Obviously, starting item should be smallest among these two. And because these both of these arrays are in ascending order, sorted in ascending order, so at the very beginning, both pointers are pointing at the smallest item in their individual or you can say respective array, correct? So you just need to compare these two items, which one is smaller, so that you can like one is smaller, so you will put here. Because one is smaller, you have put. Now you don't need to consider it. So you will move your pointer to here. Now you'll compare again pointer and pointer. Now which one have the smallest item? 2. So you will put 2 here and move your pointer here. Now you'll compare again 4 and 5. Which is smaller? 4. So you'll put 4 here. You will move your pointer here. Now you'll again compare 5 and 7. Which is smaller? 5. So you'll put 5 here and move your pointer here. Now among 7 and 8, between 7 and 8, 7 is smaller. So you'll put 7 here and move your pointer P3 here, P2 here, sorry, P2 here. 8 and 9, 8 is smaller. So your pointer would move here. 9 and 10, 9 is smaller. 9 is put here. Now nothing is there. But whatever is the last item, because this should also be included, so we'll add it here and that's all. Okay. So this is how it works. So this is the third approach in which we can use a two pointer. So I hope this is clear to you. So in today's session, we are majorly focusing upon the first one, this fellow, where our pointers are gonna move and converge towards each other. Okay. So let's move forward. Let's have this first problem first. Okay. What is our first problem? This is our first problem. So problem one is reverse array multiple approaches. We'll see how many approaches are there. But again, I gave you earlier this problem. Have you thought about it? You must have put your answer in comment, right? So let's see. The basic idea or the general thought process that comes in our mind to reverse is because we always use what do we use? Always use what you know. Okay, already. That's how you try to solve the problem, है ना? Most like a toolkit, correct? There's a carpenter. Does he go and reinvent or completely invent a new thing for his new job or new kind of problem solving? No. He uses his toolkit, whatever tools are there in it. But before that, he learns to use all the tools, correct? Similarly, you learn to use all the algorithms and implement them. So that's why whatever you have learned, you try to use it. So till now, what we have learned? We have learned how to traverse an array. Okay, in short, array traversal we know till now. So what we can do or how we can solve it by just traversing the array. So you can say that This is an array which is already in the correct order 1, 2, 3, 4, 5. If I want to reverse it, let's because I can traverse, correct? So, though you know already, you can traverse from left to right. My question is, can you traverse an array in right to left direction? Yes or no? Yes or no? Obviously, yes. Same approach. In left to right, you go from 0 to n minus 1th item, correct? But in right to left, you go from where to where? N minus 1 to 0. Yes or no? So that's all. You just need to use a loop which can start from what? N minus 1. How do you get the n? I have told you in the last session, correct? If you because here the array is given, not the length. How do you get the length? Array dot length. It is written here, okay? So I equals to n minus n. So आपने start किया है. Go till where I should be greater than equals to 0. Correct? And I minus minus. Correct? No, don't do plus plus. That's how you traverse the array in reverse order. So what we can do is, let's see here what we can do. So here we have created an additional array named result of the same length as array.length. Okay. Now in the for part, what we should be writing is for int I is equals to, later I will correct it to small I. Okay. I think it is auto correcting it, so don't mind it. Okay, what should we write? Arr dot length minus 1. Okay, because it is 0 based indexing, so array is till indexes are till n minus 1 length only. Okay, this one. Next, I should be greater than equals to 0 because we are starting from where n minus 1 to 0. Okay, so till 0 our array should be traversing. Next, I should be decremented. Okay, I should be decremented. So that's how you traverse your array in the reverse order. Now what? Let's see. Let me put the indexes also. 0, 1, 2, 3, and 4. And here your I is right now. Okay. Why? Because length is 5, 5 minus 1 is 4. Okay. So I is pointing at 4. Index is 4 right now. So now what? Now what? Is this I written correct? Is this I written correct? In result, we can't just put I directly because I is what? I is at the end, last index of this array. But in result, what do we need to do? In result array, okay, 2, 3, 4, and 5. Last item needs to be put at where? First position, zeroth position, 1, 2, 3, and 4. Zeroth position, correct? So what do we need to do? You can just take one extra variable here, okay, int j is equals to 0. Initialize it. You can just put j, okay, in result of j is equals to, this will put your item at 0th index. So what item? Array I is at the last index. Okay, so this is how you just copy the item at the last index, which is 5. So 5 is copied here. Next, what do you need to do? This I would be decremented to here by this I minus minus. But before that, you, because your j was here, na, j आपने 0 initialize किया हुआ है. You have initialized it as 0. You need to move to the next. So what do we need to do here? We can write j plus plus. Okay, so this will increment our j pointer here. Next, this loop will reiterate. Okay, while reiterating I minus minus. So I is at the 3 index now. Now result j. J is at 1 index. Okay, it's equals to, it will be assigned with array I means I index पे जो item है, what is it? It is 4. So 4 would be assigned here, and then j plus plus. J would be moved here, then reiterate, and while reiterating before that I minus minus. So I will come here. Okay. Similarly, again result j here. This position will be assigned what? Array I. I is 2, so at 2 index item is 3. So 3 would be assigned here. J plus plus, j would go here, and I minus minus, I would go here, reiterated. Okay. Still, why I am what I'm missing while dry running? Why am I missing it? Because still this condition is not justified now. Means it's not failing. Though I am always decrementing I, but I have not reached beyond zero, correct? So if I am my I is at one, let me check it. Is 1 I equals to 1? So 1 greater than equals to 0? Yes, it is. है ना? So anyway, it is getting justified. It is true. So we'll come inside real J. At third index, array I. At first index, item is 2. So 2 would be assigned here. Then J plus plus. J would come here. Okay. I minus minus, I would come here. Reiterated. Okay. Again, now I should be greater than equals to 0. I is 0 now. So is 0 greater than equals to 0? Yes, it is still true, correct? So we'll come inside. Once we are inside result J. Means at fourth index, what am I going to assign? This is assignment operator, correct? Array I. I is 0, so at 0th index, 1 is there. 1 would be assigned here. And then J plus plus. Don't worry, it is going out of bound, but we are not checking J because J and I are incremented or decremented simultaneously. So check either of them, it would be okay. It is not going to be out of bound. Now I minus minus. So I will come beyond 0, which will be minus 1. Okay. So once reiterated, it will check from here. I is minus 1 right now. Means is minus 1 greater than equals to 0? False. Correct. So this will be terminated. Once it is terminated, I am just returning my result array, which is nothing but this reversed array 5, 4, 3, 2, 1. You can see here 1, 2, 3, 4, 5, 5, 4, 3, 2, and 1. Correct? So that's how you do this. So now, how much extra space have I taken here? Let's talk about space complexity. What is space complexity? Extra space used to reach to the solution in comparison to the size of input data. What is input data? Here, array. Okay. So what we have used? We have used an additional we have used an extra array named result of size n. What is n? Size of input array. Correct? So this is the extra space we have used to reach to the solution. Okay? In comparison to the size of input. Rest of the space are int j, int I, nothing much. They are constant spaces, correct? Out of one, out of one. So this one is bigger. So that's why space complexity here would be big of and worst. है ना? Means इससे ज़्यादा हो नहीं सकता. We can't, I mean this solution can't take beyond the size of n. Okay? So that's what it is. And that's what you need to focus upon. This is the worst case time complexity. There are two more, the best case and the average case, which you don't need to focus upon right now. Okay. If you demand, I mean, if you need it, I can release a dedicated to video upon just explaining time and space complexity, each and every detail, what are the formulas, each and everything. But I think for just these interview kind of thing, if you can focus here, that would be best also. In interviews, they don't ask much about those things. Okay. But it's not like you don't need to read it. Okay. Always refer your textbooks. Okay. So yeah, space complexity is this one. Now let's talk about the time complexity. What is our time complexity? What is our time complexity? Write in the chat. Yes, because we are using just this for loop, okay, to traverse our whole array. Though this time we are traversing this array in the reverse order, doesn't mean that it is going to take any less time, because again, in forward order or backward order, you are going to traverse all n items. That's why big O of n only. Okay, nothing less than that. So here you can see time complexity is big O of n, space complexity for this approach is because you're using extra space, so big O of n. Okay. Now, I hope this is clear. Let's move to the next approach. What is the next approach? Next approach is an expert approach, okay, using two pointer. So let's talk about it in a little more intuitive fashion, okay? Why I'm saying so? Let's see here. This is the array, the index 0, 1, 2, 3, and 4, okay? Item 1, 2, 3, and 4. But, but, let me try to increase its size, है ना? थोड़ा सा बढ़ाने की कोशिश करते हैं. I hope it is okay. Yeah, that is okay now. If you look at it very intuitively, what if I just have two pointers or two references, one at here and one at here, and if I have two pointers at both ends, and I can swap the items. Swap the items. Swap the items is the key here. As you can see, if in the same array, I can swap 1 and 5. What will I get? I will get 5, 2, 3, 4, and 1. Yes or no? This is my left pointer and right pointer. Correct? And once I have swapped them, what I will do is I will put my left pointer one position forward and right pointer one position backward, means one position left side and left pointer one position right hand side. Now again, if I just swap these, so what will I get? I will get this 4 would be swapped with 2, 3 in the middle, 5 was already swapped with 1, okay, and then once swapped, what do? We need to move over left and right pointer in the directions, correct? Left to the right and right to the left. But once I do this, if I put, I mean, put my left pointer here and put my right pointer here, would this do any great thing for me? Or do I even need to swap it? Means both left and right pointers you can see are pointing at the same index. Do we really need to swap them? Now, do we need to swap them now? Answer is no. So let it be. So if you can just observe and understand the pattern here is what? In the same array, I can just swap the items and get the result. Yes or no? Swap the items and we will get the result. We don't need extra array. Yes or no? Don't need extra array. Correct? Happy? Still, we are traversing all the items. If you see a combined left and right pointers, they're traversing all the items. Half are traversed by left pointer, half are traversed by right pointer. It is nothing less, correct? So all of them are being traversed. So if I were to code this approach, what would I write here? What would I write here? My left pointer should be starting at 0th index Right pointer should be starting at array dot length minus 1. Okay, array dot length minus 1 index, which is 4. Okay, now we need to this condition while you can see here, we don't need, I mean, they are not of no use for us these for these two pointers to be at same position or crossing each other. Even if they cross each other in this moment, see here, even if they cross each other in this moment, after this कि right एक और आगे बढ़ गया and left एक और आगे बढ़ गया. So कौन सा इंडेक्स होगा? 1 होगा and 3 होगा. Correct? 2 बीच में था. 2 was in the middle. Do we really need this situation? Because this one index was already traversed by whom? You can see 0, 1, 2, 3, and 4. 1 was traversed by L pointer already. And this 3 was traversed by right pointer already, R pointer. So this will lead to repetition. We don't need it. Repetition. And further swapping will lead to, और स्वैप करके क्या होगा? Will lead to having the initial array. Yes or no? ये okay के देख लो. I really wanted to try it. Okay, take this as homework. Try it on your own. Because moving forward, if I again swap one position, three position items, two would be swapped with four. Then moving forward, five would be swapped with one. Again, क्या आ जाएगा? 1, 2, 3, 4, 5 is what you are gonna get. So that's why we don't need any further swapping. That's why we just keep these pointers from crossing each other. So that's why left pointer should always be less than right pointers, okay? Because of these conditions. I hope you are getting it. Left should be right in the while loop. Now swap the items. How to swap? While swapping, if you don't know the logic, let me tell you. Because if you want to swap, your left is pointing at 1, right is pointing at 5. Okay? Left is pointing at 1, right is pointing at 5. So you can't just give right's value to left because then 5 will overwrite 1. Okay. And your data, what was at left index, will be completely gone. So first store it somewhere. That's what we are going to do. We will first store the item at left in the temp. You can do it with right also, no issues. Either one of them you need to take to store. So ARR left would be stored in temporary variable. Then left को हम right assign कर सकते हैं. How? ARR right. Okay. Left index have assigned the right indexes item. Okay. Now at right index we need to put what? This one. But one is kept where? Left have lost it. But it is still put in temp. So that's why we will assign temp to right. This way it will complete the whole thing. Okay. So this one would be overwritten with 5 first. Then this 5 would be overwritten with 1. And that's all. That's how things happen. But once this is done, what do we what do we need to do next? You can see here, left pointer would be moved forward, right pointer would be moved backward by one position. So what do we need to do here? Left plus plus, right minus minus. And after this, this loop will be reiterated. And once reiterated, it will check this again. So you can see the next iteration like here is left less than right. Yes, it is true. So true. So again we are swapping. So 2 was swapped with 4. You can see here 4 and 2. Once the swapping was done, what are we doing? Left to plus plus. So left came to 3 like here. Right minus minus. Right again came to 3 means second index like here. Okay. So what happened next? Reiterate left less than right. But left and the right have the same index which is 2. So is 2 less than 2? Question mark. No, 2 is not less than 2. So that's why it will terminate now. Once terminated, what do we need to do? Return the same array, which is now modified completely by swapping. So here what is happening? How much extra space are we taking? Let's talk about space complexity. In comparison to the size of this array, let's say this is of size n. What is extra space? Extra space is just these variables, nothing else. Okay, so space would be constant. Why? 1 by left. Okay, left ने एक space ले लिया, right have also taken one space. Combinedly, it would be 2. Okay, 1 plus 1 equals to 2. Most layman way, this is what I am teaching you. Okay, 1 plus 1, 2. But is 2 any way comparable to n, which can be of the order 10 to the power 9? Is 2 equivalent to n? No, it's very, very tiny. I can say negligible. Negligible compared to this fellow. So that's why once the things are negligible, we call it constant. And how do we show constant? By showing big of 1. Okay, so that's why space complexity is big of 1. But what is the time complexity now? Again, though it is a while loop, okay, how many times it is running? Tracing all the n items, but 2 items at a time, correct? So worst case कितना होगा इसका? n by 2 हो जाएगा, yes or no? Number of iterations. Number of iterations. Because in each iteration it is tracing 2 items, okay? But again, n by 2, how do you define it? Is it correct to write n by 2? See, this shows worst case. Worst case, correct? Worst case. So, worst क्या हो सकता है? Let's see. If instead of n, I go to n by 2. Let's say my n was billions में तो होता है, but n was 5 billion, 5 into 10 power 9. तो n by 2 कितना होगा? 2.5 into 10 power 9. Correct? Or let's give it proper number. 6 कर देते हैं, इसको 3 कर देते हैं. I think now this will make more sense for you. Is the order of this number changing much? If I do n or n by 2, is the order of the number changing much? How many digits are there? 9 plus 1, 10. 9 plus 1, 10. Total 10 digits are there in both ways. So that's why in worst case notation, you can always write n by 2 as n. It doesn't make much difference. Okay. I know what you're thinking. Sir, n by 2 मैंने 4 लिया, n by 2 2 हो गया, बहुत छोटा हो गया. 100 लिया, n by 2 50 हो गया. 1 billion का n by 2 half billion हो गया. 500 millions only. But in computer science, we don't calculate in that way. Things are a little different. Okay, things are calculated in terms of order. So you can see the size of n is here, 10 digits. Here also even n by 2, 10 digits only. This is just for you to show the comparisons. Okay. So that's why n by 2 can be written as order of n. Still, the answer won't be wrong. Okay. So yes, let me repeat. Space complexity constant, which is big O of 1. Time complexity n by 2, which is big O of n only. Okay. I hope this is clear. So now you can see that in these two approaches, it's quite clear which one is better. Which one is better? If you can see here also time was order n. Here also time is order n. But here the space was what? Big O of n. Yes or no? And here in this approach, 2 pointers space is constant. So who is the winner now? This fellow is the winner. 2 pointer approach. Okay. I hope you will remember it. Correct? Okay. So let's move forward. Move forward to what? Let me just take one more page to show you what is palindrome. Okay. Palindrome are the arrays or strings. Strings, don't worry about it. I will cover in the next half. Means next half of the series. Okay. Can be read same from both sides. Okay. Can be read same from both side. Like क्या check कर सकते हो आप? So you need to check if a given array is palindrome or not. Like 1, 2, 3, 2, and 1. Is this palindrome? If you read it from left to right, 1, 2, 3, 2, 1, है ना? 1, 2, 3, 2, and 1. If you read it from right to left, again 1, 2, 3, 2, and 1. Correct. This is palindrome. But if I have 1, 2, 3, 4, 1, is it still a palindrome? Let's see. Left to right if I go, left to right. Okay. Left and right. 1, 2, 3, 4, and 1. But if I go from right to left, what will it be? 1, 4, 3, 2, and 1. Are these same? Not same. Okay. L2R ये R2L है. This is L2R. This is R2L. Okay. These were same, but these are not same. So that's why not a palindrome. So now you must be getting the idea. What is going to the best way? Use two pointer to solve this. Best way to solve this. Check if a palindrome or not. Use two pointer approach. Okay. Now you can see here. If I read it from left to right or right to left, it became same. Means 0, 1, 2, 3, 4. In left to right, the items was in this index fashion, but in right to left, we read one first. What is the index? What is the index? 0, 1, 2, 3, and 4. So this was fourth index, this was third, second, first, and zeroth index, correct? So you can see zeroth index and fourth index item are compared directly. They are same, then first index and third index items are compared directly. If they are same, then second index and second index. Second index item, you don't need to compare because anyway they are same, correct? But now moving forward, you can see that third index and first index are getting compared, which we have already done here, 1 and 3, same here. Fourth and 0, which we have already done 0 and 4. So we don't need this comparison. Yes or no? Don't need this. What comparison do we need? Comparison 0 to 4, 1 to 3. If it is even, 2 to 2 is not required. If it is odd, then 2 to 2 is not required. Even है तो हो जाएगा. This sequence में रहेगा. So this clarifies that you can use two pointer approach here. Yes or no? एक लेफ्ट में रखो, एक राइट में रखो. लेफ्ट राइट कंपेयर किया सेम है, मूव फॉरवर्ड, मूव बैकवर्ड्स. लेफ्ट राइट कंपेयर किया सेम है, yes it is. 2 and 2 are equal, so move forward, move backward. They are the same position. Left should be less than right. Till that condition met and you were out of the loop, then return true. Otherwise, in any case, if it was not same, like here, left and right. One is same with one, yes. Move forward, move backward. Now 2 is equal to 4, no. So return false here. Correct? That's how. And again, what is your time complexity? Same as the approach we used in reverse order with two pointer big O of n. Space complexity would be big O of 1. Write in the comment what naive way you are going to use to solve this. Okay? I really want to know. Though I have showed you the optimal way, but show me the naive way in the comment. Okay? Please put it. Moving on. Again, as I told you earlier, I will show you the comparison side by side. So if you, in the array reversal, if you take a new array, the time complexity will be big O of n and plus space complexity. What is this for? For taking an extra array. Okay. So best for arrays when origin must be preserved, है ना? Order अगर preserve करना तो आप ये use कर सकते हैं, but if order doesn't matter, then you don't need to. So in two pointers, order n, order one. Okay, because we are doing it in the same array. So interviews and real systems में ये काम होता है. So two pointer leverages arrays random access capability for order one swaps, है ना? वहाँ पे constant time ही लग रहा होता है. Don't worry कि swap बहुत time लेता है. Okay, because index based swapping है, so it takes order one only, constant time, random access, which I showed you in the last class also, because predictive address होता है array के पास, arrays, this predictive address because of the index, predictive address because of the index, that's why fast access is done, or in this case you can call it random access capability also. Okay, I hope this is clear. Let's move to the next problem. Next problem is about two array. Okay, sorry, pair sum in sorted array. I just said two array. Okay, paired sum in sorted array. So let me just show you the problem statement in brief. That's how the problem statement usually is. Okay, and only this kind of problem statement. Okay, I need to take the pen. This kind of problem statement is given in different ways. It can be given in some paragraph through some story also. But this is the most directed way of giving this problem. Okay. So sometimes it happens that you need to first figure out what the problem statement actually telling you, though it have some story, but you need to filter out the whole unused part and the used ones. Then you understand, oh, it is the same problem that I have solved. It is saying nothing but just I need to find the pair sum in sorted array. Okay, so let's see this. So you must be given with the sorted array and a target sum. You need to find if there exists a pair summing to target. Pair means pairs usually contains how much? A pair of shoes contain how many shoes? Two items. Yes or no? Pair contains two items. Pair of shoes, two shoes. Okay? Two shoe. So input array would be like 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay? This is your input array. And target is 7. So 0, 1, 2, 3, and 4. This is the array. T is equals to 7. So you need to tell are there any two items in the array whose sum is equal to 7. Hey, kya? That's what they're asking for. Two items because they asked for a pair. Okay, pair. So let's see how many items are there. Though it is clearly written here also. It is clearly written here also. 2 plus 5 equals to 7. Okay. 3 and 4 can also give 7. 2 and 5 can also give 7. Okay. But in this question, they're not asking how many pairs are there. They're just asking find if there. Means find means tell true or false. That's all. So here you must have now found out that this is one version where just you just need to tell true or false. There can be another version of this question where they can ask what are the pairs? Sorry. What are the pairs? Okay. Any first pair, I mean, they can ask any first pair. So 2 plus 5, 2 and 5 also can be answered, 3 and 4 can also be answered. And the version of this question can be how many such pairs are there? So you can probably do what? Count also. So the base logic, the foundation logic is going to be same. Okay, I will show you. Rest you just need to put a counter here and then that's how you will do it. Okay, so I hope this problem is clear. Let's move towards the solution of this. Okay, approach part. What is the approach here? So let's see. First approach that we can think of or we can try is what? Naive approach क्या होगा? What you can think of? What you can think of? Please add in the comment. What you can think of as a naive approach here. Of course, you need two items, you know? You need two items whose sum equals to 7. Correct? So let's say I know how to traverse array. I always tell you. First, try to apply what you know already. Okay? You know how to traverse. So if I go from left to right, for this very first item, I know this is 1. So 1 plus what will be equal to 7? Correct? Plus what will be equal to 7? So I will traverse rest of the array, like I will write 1 plus 2 is equals to 7. Then 1 plus 3, first I will check 2, then 3 is equal to 7. Then 1 plus 4 equals to 7, and 1 plus 5 equals to 7. Okay? सबको check किया लिया. But none of them are equal to 7. And now I have no more item to check also. Then what will I do? I will again now come back here and try to, first I fixed 1, now I will fix 2. And from here, I will try to make up a mesh from the rest of the items. Up, I don't need to look backwards. Why? We have already looked at the pair of 1 and 2 when we fixed 1. So we don't need to look backwards. With 2, look forward. With 2, what are the combinations? 2 plus 3. First we will traverse 3 with another loop. है ना? Here you can see that we need what? Nested loop. Yes or no? One loop to fix for the first item, and the loop to traverse rest of the items to see if they are adding up to the target item or not. So 2 plus 3 equals to 5. Then it is not equal, so we will move to 4. 2 plus 4 equals to 6. It is also not equal. Not equal to 7. Not equal to 7. Okay? Not equal to 7. So we will move to where? We'll move to 5. And we'll check 2 plus 5 equals to 7. Yes, it's equal to 7. So we do what? Return true. Okay? Because they just need it is true or false. If they want more, then you can probably check more. But till here it will work. So now you must have seen what the brute force approach is telling you. So we first need an iterator I index, okay, equals to 0. Okay, probably because I'm putting in space that's why it's giving. So let me remove this space, you know, so that I can avoid. I should be what? From 0 till where should I take my I? Tell me quickly. From 0 till where should I take my I? Let in the comment quickly. Yes. 0 start हो रहा है कहाँ तक जाएगा? Last item. You can take one item first because you need pair. Correct. Going last item then running J loop from there doesn't mean much. But for safe side to avoid mistakes, you can do that because anyway the constraints will keep that in check. Okay. 0 till I should be less than array dot length. I should be less than array dot length. Okay, minus 1. Or should I not write it? Is it correct or not? Please write in the chat because I have a quiz on this also. Don't worry. If you're getting it correct, it is correct. Otherwise, you will learn while solving the quiz. Okay. I should be less than array dot length and then here I plus plus. Okay. For this for outer for loop. Now, what for the inner? Inner, let's take another iterator j. Okay, and j equals to what? If I'm putting my outer loop with 1, I don't need to put the inner loop at 1 as well because then it will do what? It will check 1 plus 1 if I put I and j both at the same places. 1 plus 1. This should not be happening because same item se pair थोड़ी बना सकते हो. You can't take, in the question it was not mentioned. Anyway, if it is mentioned, then you can. Otherwise, no. You can't take the sum with the same item. So that's why you need to put your j here at the beginning. So j is nothing but j is equals to I plus 1. Wherever I is, j would be at the next position. So that's why j is equals to I plus 1. Okay. Next, again, same thing for j also. J should be less than array dot length. Okay. And then j plus plus. Okay. This is how it is gonna be. Now, once I know the iterations, so I was doing what? I plus 2, I plus 3, I plus 4. But how do I do this? So I would have to write the condition. If the sum of these items at these indexes is equal to target or not. So if item at ith index in the array plus item at jth index in the array is equal to. Okay. This is a comparison operator, not the assignment. Single equal to is assignment operator. Okay. Is equals to target. If it is true, means like here, once we have found 2 plus 5 equals to 7, equals to 7, it is true, then return what? True, nothing else. Okay. But if it is not true, then anyhow this whole for loop is gonna run and completed. Okay. Like we did for 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5 was done. It was not a match with 7. Then instead of 1, 1 got replaced with 2. Means inner for loop was exhausted, then outer for loop will be running again. With what? I plus plus हो गया था. So 1 से I कहाँ गया था? Second index में which have the item 2. So now 2 is fixed. And j would be what? I plus 1. So j would be here now. Okay? Instead of this place. Now what the comparison would be started? Because it was fixed already. So 2 plus 3, 7 and नहीं है. It will reiterate. 2 plus 4 is 7 and no, it is not. Reiterate. 2 plus 5, it is 7. Yes. So once 2 plus 5 equals to 7, it is true. It will return true. That's all. Let's say if target was not 7, if target was, you can say 10. So even though you check all the combinations of the items, this return true won't be hitting anyhow. Okay, this will always be false. So once this loop is over, over, you will come to this place. So once you come to this place means this tells you solution was not found, correct? No such pair found. So what do we need to do? Return. We need to return false from here. Okay, we can quickly return false like this. So this approach, I hope it is clear, and this approach takes what? Time complexity is what? You can see nested loops are here and both loops are running completely. You know? Worst case big of n square, space complexity. Here we are not using much of any external array or extra space, so only two additional you can say variables I and j, that's all, and target to calculate the sum. So it is still constant. Sort of one. Okay, this naive way. So this you can see this is polynomial, है ना, n square में आ रहा है. So keep it in mind, it is not very optimal, not very optimal. Okay, let's have a look at another approach. What is the other approach? The other approach, let me just, yeah, magnify it and then we can discuss. The other approach can be using hash set. For those who don't know it yet, let me give you a brief idea about it. It is more like recording what you have already traversed, okay? Records what you have seen already, okay? So to make hash set, we use what? I will tell you. We use set, okay, in Java. So how do you use set? We create a set. How to create it? Just write set, and what are we going to store in it? The data type integer, because array have integers only. Let's name it because we are putting all the scene items, so we'll be putting scene. Why I'm doing so? Let me tell you in very short time. Okay, don't worry. New to allocate this space, then hash set, and then this thing. Okay, this is declaration and initialization. Okay, now we need to put item in it, but we have not seen anything yet. So what we can put? So let me first give you the idea why we are using it. Okay, earlier, if you seen this approach, if you there's too much of redundancy, yes or no? There's too much of redundancy. Why? Because we are just calculating blindly. कि दो numbers को we are picking two numbers, adding them and checking if their sum is equals to 7 or not. My point is, why do we need to pick two numbers? Question is, please listen to it very carefully. To solve this, why do we need to pick two numbers? Actually, we don't need it. है ना? Why? Let's see. You already have target, है ना? And while traversing the array, like array, what are the items? One, two, three, four, five. Look at it very carefully. है ना? What if, because I am traversing this whole array, this is zeroth index, first, second, third, and fourth. If I am at the very first index, which is 0, I know this is item, this index of item 1, correct? And I have target already, target T, which is 7. So I have two numbers now, correct? When I am at the very 0th index, I have got two numbers among the three, 1 and 7. If you're not getting it, let me convert it. Isn't it looking like A plus B is equals to target T? Yes or no? So among A or B, you already know A, you already know T. So can't I write the formula B is equals to T minus A? Yes or no? So that's why this is what you need to focus upon. You don't need to pick two items at a time. Okay. You already have one. You already have target 7. So when you are at this zeroth index, what you need to search? You need to search T minus A. B equals T minus A, which is equals to 7 minus 1 equals to 6. So just need to check for 6. But if I say again, sir, you just said I need to traverse once, I need to find one number only. Again, you are saying, sir, subtracted, I am getting 6, so I will need to find 6. And 6 is not even available here. So again, I would be going in this nested loop. But here's the catch, you don't need to. Just check if you have already seen 6 or not. Somehow, just hypothetical way for the beginning, but later you understand. Na? So here you check while at 1, subtracting from 7, you are getting 6. You will check if you have seen 6 earlier while traversing this array. So no, because you are at the very beginning of this array. So you will do what? You will keep a set. है ना? एक set आपने बना रखा है where you are putting all the scene items. Okay? Set put all scene items. Okay? So before one you have not seen, but now that after reaching one or a zeroth index, seeing one item, you are anyhow going to move to next position now. So because now you have seen 1 already, put 1 here. Okay. Now once you are at 2, what are you going to do? Again, b is equals to t minus s. So 2, 7 minus 2 will become 5 now this time. Once you are at 2. 7 minus 2 equals to 5. You will try to check. Have I seen 5? Is your scene set have 5? No. So what are you going to do? No, I have not seen 5. So till here I don't know if there is 5 or not. But I am sure about 2. Okay. So you will move forward, but before moving forward, because you have seen 2 also, so put your 2 in this set and move forward. Okay. Once you move forward, you are looking at 3. So again, the next item which is missing would become 7 minus 3 is equals to 4. You will check in your the set, scene set, if 4 is available. No, it is not. So till here you have not found 4 also. So let's move on. What will I do? I will put 3 here and move on. Now I've got 4. So B is equals to क्या हो जाएगा 7 minus 4 equals to 3. Correct? I need to look for 3. Have I seen it before? I will go and check my scene set. Yes, 3 is available. And it tells you very quickly. Don't worry. Searching in set takes order of one constant time later. Don't worry about it. Yes, 3 is there. Yes, I have seen it. अब seen it का क्या meaning है? What does it tells you? Seen it means you are already at 4. To find or to tell if a pair whose sum is 7 exists, you just need to tell you have 4, you just need to tell if you have 3 also or not. So before 4, you have already seen 3 also. You know it. है ना? Why are we doing this? You must be a little confused. कि sir, why are we doing this? Initial तो हमारे पास सीन में कुछ था भी नहीं. Just try to understand. 1, 7 minus 1, you got 6. What if 6 was here? I know. And once you reach 6, what you will do? 7 minus 6 equals to 1. So because we are storing what we have seen already, so it will again give you correct answer. Yes, so 1 तो पहले देख रखा था. So either you are at 1 and you can say 6 आपने देखा है नहीं देखा है, you have already seen 6 or not, or else you are at 6 and you are saying if you have seen 1 or not. So once you reach 6, you will definitely say yes, I have seen 1 because it was there earlier. So that's how this logic is working. Okay. I hope this is making sense to you. Correct? And here, as you can see, I'm traversing this whole array once only. And while traversing, I'm comparing and putting it in the my set. So let's see the whole code here, how this is working. Okay, how this is actually working. So we have created our hash set. Now let's try to traverse this array. So again, int I is equals to 0. From the beginning, we are traversing it. Then I should be less than array dot length, then I plus plus. Okay, this is how it is gonna be. Next, let's create a variable named difference because we need to know what we need to look if we are at the current item. So difference is nothing but b here. Okay, b is equals to target minus item at index I. Okay, my current index is item at index I. So you will get the difference which is B. Once you get the B, you will check what? Now you will check if you have seen B. So if in this if statement, because my set that I'm using is also named as scene. So scene dot, this is a Java function. You can directly use it to check if item is there or not. It takes constant time, don't worry. Contains scene dot contains diff. Okay, the number I am looking for as a difference. If it contains, it will return true, otherwise it will return false. Okay, simple. So if it returns true, you just need to write return true. Why? Because if this if condition is true, means you have found a pair. In what? Array I plus difference is also you have in the array. Both are in the array, means you have found the target pair. So that's why I need to return true. Otherwise, if you have not seen it, then what did I do earlier? Like for 1, the difference was 6. I have not seen 6. So what will I do? I'll put 1 in my scene and move forward. So I will put 1 in my scene. So scene dot add. Okay. What add? Item in the array at ith index. I've added it. That's and then the whole for loop will be reiterated. Okay, as you have seen it earlier. But once this whole thing is done, okay, this was never true. Means my for loop is over now, and I have got nothing while I was in this whole for loop. So what will I do next? Return false, maligning, because your search is over. I mean, termination of this for loop tells you your search is over. Termination of this for loop tells you the search is over and you have not found the pair item and you have not found the pair item. Okay, that's how it happens. So now let's quickly just summarize the solution. What would be the space complexity here? We are using this extra set, and because the items can be unique, so worst case out of n. Okay, worst case out of n items तक ये जा सकता है ना? Let's say this 3 4 was not here. Let's say at the end you was 6 and this was 1 only. Okay, even 5 was also not here. This was somewhat 12, 14, 16, and 6 was here. So what will happen? Only 1 plus 6 can give you. So till you reach 6, all items would have been kept in the set. So that's why order of n. And that's a additional space you are using in comparison to the which is similar to the order of input items. Okay, input array. Time complexity. Searching here in the set is checking big of one only, not much. Okay, it's a Java function. You can read about it in the documentation. Don't worry. This is also getting done in order of one constant time. Nothing much. So only major time is it's taken by this for loop, which is again n times it is iterating over all the items from beginning to the end. So that's a big of n. So space complexity is order of n, time complexity is order of n. Now let's compare. Earlier we saw space was constant, but time was what? Polynomial, and square is too much, not very optimal. But here we have a trade-off. We have a trade-off now. And what's that trade-off? Though the time has become linear, but constant space अब कहाँ गया हम extra space use कर रहे हैं extra space. Okay, this is my extra space. That's what the trade-off here. I hope this is clear now. So let's move to the next one. Next one is this approach. This approach is about two-pointer approach. Okay, this is gonna be very interesting. People, be with me. Okay, very interesting. How interesting it is gonna be? Let's see. Let's try to see how we can apply two-pointer approach here. Let me try to write the indexes first. 4. Okay, 0, 1, 2, 3, 4 index. If you must see that earlier we were not considering even if the array was sorted or not. But here we are considering. Why? Because sorting earlier two approaches can work upon sorted or unsorted array both. Okay, so that's why I didn't mention anything about what advantage does it give us while this array is sorted. But here we have an advantage with the two-pointer approach. What is that advantage? But it is not gonna work on unsorted array. Okay, not, I mean, this particular approach not gonna work on unsorted for this particular problem, okay? For this प्रॉब्लम अभी वो लेटेस्ट से सर आपने तो कहा ही था होगा, ऐसा नहीं है, इस पर्टिकुलर प्रॉब्लम के लिए नहीं है, ठीक है। टू पॉइंट अप्रोच और भी कई जगह यूज होती है, इट इज यूज्ड वाइडली एट many places, okay? So here let's see, if I take two pointers, one is left, one is right, what advantage does it give? Target क्या है? 7. Target is 7, okay? So if I have two pointers pointing at the first and last item, and if I sum their items, so 1 plus left plus right अगर मैं कर रहा हूँ 1 plus 5 is equals to 6. So is 6 greater than 7 or 6 less than 7? Which one is it? Or 6 equal to 7? Equal to 7 मिल गया तो बहुत अच्छी बात है. We will just directly return true if it is equal to 7, but it is not. Is 6 greater than 7? No. 6 less than 7? Yes. But if 6 is less than 7, then what should we do? To increase, then what to do to increase the sum value? Let's try. Though it is a part of observation, but let's try anyway. I don't have any item before left pointer. I don't have any item after right pointer. So only items left are in between left and right. But at a time, I can either use this or use that. Why? Because one के साथ हो सकता है 1 plus 4, 1 plus 3, 1 plus 2 के chances है. But if I stick to left, but move the right, है ना? If I stick the left but move the right, है ना? ऐसा कर दे तो. But if I stick the right and move the left, then क्या होगा? Please focus upon the colors, है ना? If I fix the right, मैंने right fix है तो 5 fix हो गया, plus move the left. Left move के अंदर 2 आ सकता है, 3 भी आ सकता है, and 4 can also come. These are my possible choices. So how to pick one of these? Because if I do this again, then this is no different than the previous approaches, है ना? So I'm exploring all the possibility. But there is a catch here. Look at this. Why did I show you all three comparisons? If 6 equals to 7, completely okay. है ना? अगर sum same आता है तो you can return true, but it is not equal to 7. Then there are two major deciding factors to decide which pointer to move, left or right. So 6 is greater than, sorry, 6 is greater than 7, false. 6 is less than 7, true है. Now look at this. If I move my right pointer but fix the left pointer, means 1 plus 4 किया तो कितना आ रहा है? I'm getting 5. Earlier it was 6, now I'm getting 5, means और small हो रहा है. But if 6 was already smaller than 7, do I need to make one more smaller sum than 6? No, no use. So what do I do? Now I'm finding pattern that if I fix my left pointer and move my right pointer, fix L, move R, gives you decreases the sum. Okay. But at the same time, if I fix R and move L, this will do what? I fixed R and moving L. है ना, 1 से 2 पे ले गया मैं. 5 plus 2 equals to 7. Correct? So this increases the sum. This is the two principle that we need to work with while using two pointer. That's all. Okay. Because let's say यहाँ पे 7 नहीं मिलता, अभी 7 मिल गया तो 7 is equal to 7. In next addition you will get, है ना? तो I fixed it right and I moved my left pointer. So 2 plus 5 gave me 7, which is equal to my target, है ना? So this will become true. Let's say नहीं मिलता. Let's say नहीं मिलता and यहाँ पे कुछ और पुट होता. तो सिनेरियो पे हम लोग we will decide according to this result कि किधर मूव करना है. So only moving and left and right pointer, the decision of moving left and right pointer is the key of this kind of solution. Okay. So left would be at the beginning, 0th index, right would be at the end, array dot length -1. Okay, -1 is the key here, not just array dot length. While left is less than right because you don't need to cross each other. Okay, तो यहाँ क्या लिख सकते हैं? Int sum is equals to sum or current sum, whatever you want to take. Okay, item at left plus item at right. Okay, this is what I am doing. Next, what I need to check if sum is equal to of what? Three conditions. Our if sum is equal to my target, then directly return true. Okay, that's what I would be doing. Otherwise, what I will write, else if what my sum is less than target, means I need to increase the value of sum to reach close to target. In that condition, I will do left plus plus. Here you can see fix, right move L, है ना? Increases the sum. So left plus plus. Otherwise, what do I need to do? Else, यहाँ तो हमने क्या किया था? Fix किया था right को. Now you need to fix left and move right. So right minus minus. Okay, that's what we need to do here. Right minus minus. And once this whole while loop is over, you have tried all the combinations, है ना? सब check कर लिया, but this line never got hit, never got executed. Then what should I return once the while loop is over? I will return false कि भाई नहीं है हमारे पास पेयर इस array में नहीं बन सकता. Okay, so that's what. Let's say the target was 10, है ना? In that case, though this whole loop will be terminated, but it will never be true, है ना? So it will turn false. So let's see what would be the time complexity and space complexity here. Again, because you have heard it or read it already with me. What is the time complexity for this approach? Because often we have seen it already in the reverse part because the idea is same, moving end of left and right. There we were moving it together. Here one by one. Again, they can't go beyond traversing these n items. They can't go beyond. Correct? So that's a worst case big of n. Space complexity. How much space are we using? No extra space, no set is there, no extra array is there, only variables. So only variables take constant space, which I showed you earlier. If the extra space is not similar to the order of the input, which is order of n, can be billions. So it is constant. It will be considered constant. That's why space is constant. Okay. I hope this is clear to you. So now you can see first one order n square time space constant था, but time बहुत ज़्यादा था. Time is too much, not optimal. Here there's a trade-off. Though it took order of n time, but at the same time it took extra space also. So these two will work on the unsorted array. Correct? Hash set अच्छा देगा. But if the array is sorted already, because sorting takes time है ना, फिर तो dominating हो जाता है. You will learn later कि how long does it take. Usually sorting takes big O of n log of n, which is greater than big O of n. Okay. So ये dominate कर जाता. That's why if the data is sorted, then use two pointer. Otherwise, you can go with this fellow because with this trade-off, it can still give you big O of n. Okay. Time अभी भी अच्छा मिलेगा आपको. So that's how this is. Next, move to this table. Here's some complexity. You can see here, brute force gave you order n square, space order 1. Small arrays you can use, not on big arrays. Worst case. I mean, worst, you can say solution. Hash set, order n, general case, unsorted data. Two pointer, order n, order one. Works on unsorted? No, it doesn't. So that's why use it on sorted arrays. That's how. So two pointer exploit the sorted property to make intelligent decisions. Don't forget it. Okay. Let's move on. Here's a quick exercise now. You can see because we were talking about time and space ना. So you can see as I was telling you कि कितना होता है. So array है. This can be order of n है ना size का and n can be of billions of bytes. Okay. Now let's see here. Int left equals to 0 takes because left is an integer variable 4 bytes. 4 plus right equals to array dot length minus 1 again 4 bytes plus 4. ये हो गया. Then current sum or sum I used, okay? Plus 4 again. 12 bytes. Correct? So this is the extra space that we have used in our solution of two pointer. So is 12 byte क्या 10 power 9 bytes के अराउंड है कहीं पे भी? हाँ? No, it's negligible. है ना? That's why order of 1. Okay, space. So here you can see ये 2 pointer का था and root में इतना था hash set में order of n था. I hope this is clear now. Now, one quick question I would really like you to answer and put your answer in the chat. So, for sorted array of size 1000, sorted array means we are talking about a two pointer approach. How many comparisons in worst case? Worst case में क्या हो सकता है? In worst case, left and right pointers, correct? Worst case ये सकता है if the target is greater than sum of largest and second largest item तो क्या हो जाएगा ये राइट विल ऑलवेज बी फिक्स्ड हियर बट लेफ्ट आपका पूरा पूरा चलता जाएगा एंड एट द एंड you will figure out that you are not able to find the solution. So कितने comparison हैं total? If the size of the array is 10,000, so 10,000 comparisons would be in worst case. Okay, that's what is the answer. Which approach is best for unsorted array? We just saw two pointer काम नहीं करता unsorted array पे to give you optimal solution. Brute force unsort पे काम करता है but for small array. But they are asking for best solution. So hash set would be the best solution. Okay, ये भी नहीं होगा. मतलब brute force नहीं होगा. Okay, so I think this is the answer. Moving on. Now, why this was important, as I told you, all the farm companies always ask questions upon these. So in Google, this kind of question have been asked. Given a sorted array, find two numbers that sum to target. Clearly, this same question just asked in a different way. Amazon reverse an array in place without extra memory. So we used a two pointer technique to reverse in place without using any extra space. In place का मतलब होता है without using extra space. Okay. Next is Microsoft. Check if array is palindrome without extra space. Same. Okay. So this is what it was. Now talking about moving forward because today's topic are over. So what you will get when you join our sessions, Aarush coaching sessions. Okay. We are telling you about the best practices when you're working with the arrays. So when to use pointed two pointers on arrays, our sorted arrays पे काम करता है. In place modifications required. These are some pointers which you can use further to understand or to identify where to apply it or where to not. Okay. Order in space constant दे रहा होता है आपको. Next है space most of the time. There are some problems, kind of problems, so you can use array reversals में you can use. Okay. When to avoid unsorted data होगा, avoid using two pointer, instead use hashing. Okay. Need to preserve original array because two pointer jumbles the order है ना, last and first सब match करता है. So if reserve the original array then don't use it. Random access patterns, randomly कोई data access करना है not in some order, then again एक किसी pattern में भी नहीं, then again don't use it. Okay. Next, today's key takeaways. So we have mastered two approaches for array reversal. What was that? Extra array and two pointer. Three approaches here. So brute force, hash set, and two pointer. Then time and space comes to be covered. Optimizations we talked about. And when to use two pointer versus hashing is also what we talked about in last slide. Okay. Now, as a specific insights, you already know this. We already talked about it, you know. But always consider before applying to pointer is the array sorted or not. Okay, please check it. Next, homework. So I will really like you to solve these questions on lead code. Okay, because you have already learned the basic to solve these. Please try all the three approaches on these questions. These are two easy and two medium questions. Before coming to or joining to next class, please solve this. This will be very helpful for you. Anyways, I will be discussing two more questions tomorrow. Okay. Now, just to get more of this kind of content, if you are feeling that you are learning something, you are getting some value, then please subscribe us. In this series, if you subscribe us, you will be getting 30-day focused area and string mastery, multiple solution approaches with complexity analysis, real interview questions breakdown, okay, like I showed you earlier with the FAANG companies, then structured learning path, interactive doubt solving, okay? That's how we can help you. And at the same time, your support also help us to create more array pattern videos and on other data structures as well, advanced optimization techniques and company specific preparation guides. Because at the end of the day, the placement matters, right? In preview. Tomorrow, what we're going to do? Advanced two-pointer patterns on arrays and continue with the most water problems, trapping rainwater problem, and more array specific optimizations. Okay. So don't forget, mastering array is your first step towards the essay excellence. There is more to come, but before that, more you need to master multiple algorithms as well in the same data structure which is array. So today you learn to think optimally about arrays problem. It was a win-win day completely. Okay. All the best, people. Let's meet in next session. That's all for today.